discuss about the DAX, okay, data modeling in Power BI and DAX, okay. Subsequently, we will see the reports, okay. So, what is a data model, guys? So, when a data set is available in Power BI environment, so is it called a data model? Now, to see the data model, this is the model view. You can just click on this, okay. So here we have a lot of data sets, okay, and there are linkages available. So let us just close this data set, this file, because it is related to transformations. Okay, now we do not have any data set here, okay. Let me just load one data set. So let me just connect to a data set. Now let us just load one data set, okay. This data set. So here we have these columns in this data set, okay. Sales 2015, we have customer key and these things. So guys, before we get into data modeling, so whenever we load the data, as we have discussed yesterday and also today, whenever we load the data into Power BI environment, we have to do transformations, right? Like data is ready for using in further calculations or visualizations. So in order to ensure that, what we have to do, we have to do certain transformations. Especially we have to ensure that data types are correct, and any null values, blank values, irrelevant values, all those things we have to remove, and we need to keep up appropriate column headers. All those things we have to do, okay. So that's the first step. So we have loaded this data set, and here if you see, there is, summation symbol. Are you able to see summation symbol here? So just imagine, in the Aadhaar database, you have, Aadhaar number and name of the person, mobile number and address, other details, okay. So especially the Aadhaar number, mobile number, do you get any significant insights when you do summation on these Aadhaar numbers or mobile numbers? Similarly, like your staff numbers or bank account numbers, okay, you won't get any meaningful insight by doing statistical analysis of those things, isn't it? Sum, average, median, all those things, standard deviation, there is no point in doing that, okay. The data types are numeric because of two reasons. One is, we need to uniquely identify each record. That is one thing. That is the purpose of primary key. And second thing is, we have to quickly retrieve the data, okay. When it is numeric data type, we can quickly retrieve the data. That is, you might be aware of it in relational databases, SQL and other languages, okay. So these are the two primary reasons why mobile numbers or the Aadhaar numbers, they are numeric in nature, okay. Similarly here, you can observe this customer key, product key, territory key. They are numeric, but as of now they are summable, okay. So with this background, whatever we discussed, there is no point in doing the summation on this, isn't it? So what we can do is, in the report view, we need to just click on this column, and here you can see summarization. Are you able to see under the column tools? Summarization is there, okay. You can pull down this, and these kind of summarizations can be done on numeric data types, okay. So what we can do is, we can select don't summarize, okay. So these kind of settings we need to do prior to data modeling. So product key also, let us select product key. And territory key. Okay. So order quantity and line item, okay, they can be there. So what we will do is, let us load another data set. These are CSV files, guys. Okay. So let us just load, say, territories. Okay, in territories also you can see here sales territory column. So here sales territory key, we have changed it to I mean we have changed it to don't summarize. Okay, now let's go to the data model. Here now, are you able to see? Can we call this as a data model? See, the data model means there should be some relation between the data sets. Okay, some connection between the data sets. So you will be asked about the data models in the interview and what are the different data models that are available in Power BI. Okay, so here they are independent, they are not connected. Okay, so we cannot call this as data model. Okay, now what we can do to create a connection, what we can do is just we have to know what is the primary key, what is the secondary key. Okay, so here you can see here, this is the territory table. Okay, so sales territory key, this is the primary key in this particular table in this data set. Okay, and this territory key is how do we know which is primary key, which is foreign key? You can just see in the data view. So if there is no repetition of any key, okay, that is a primary key. And when there is a repetition, you can see here, when there is repetition, this means it is a foreign key. Are you all getting? So here product key also repeated. Okay. Now, in order to create a connection between these two, or relationship between these two, what we can do is, you can just drag and drop the related columns. Okay. So here one very important thing to create any connection or any relationship between two data sets is that the data types of the connecting columns must be same. I am repeating, the data types of the connecting columns must be same in order to create any meaningful relationship. Type means we have numeric data type, or we have text data type, we have date data type, boolean data type, different data types are there. Okay. Now here, in order to create a join between these two, or relationship between these two, what we can do is just drag and drop it on this column. Okay. Are you able to see? Connection has been established. Okay, this is the connection, this is the relationship. Okay, now we can call this as a model, data model. Okay, because they are connected. So here you can see one and star here, and there is a direction. Okay, so what does those things signify? So in Tableau we have different connection types or relationship. It is called cardinality. Okay, so we have one-to-one cardinality, means one column, one value in the this thing. Okay, this is called the primary key. So primary key here in this table, one value of this column will have one matching value here. Okay, that is called one-to-one mapping, one-to-one relationship. So when we have one and star, it is called one to many. Okay, the star indicates many. So here, for one value here in this territories, you have many values here in the sales. So that means this is a foreign key. And similarly, another type is star to one. Okay, so it is many to one. One to many to one are basically the same. Okay, only the direction will change. And the final thing is many to many. Okay, that means there are no foreign keys. There are no primary keys. So you have multiple values matching in each of the table. Okay. So here this direction indicates that filtering is happening from this direction, from this primary key. Okay. So when you create visualizations, filtering happens from the this territories key. Okay. Now, so guys, in Power BI there are two models. Okay, basically there are two data models. One is called star schema, another is called Snowflake schema. Okay, so let me just show you the. Now, before going into the schemas, you need to understand a few terminologies. So there are two tables are divided into two types. Okay, one is called dimension table or lookup table. Another is called fact table or data table. Okay, so this dimensional table or lookup table is like it will have all the definitions. So it will have the categorical information or it will have the setup information. Okay, like you just imagine a typical bank. Okay, in a bank, when you open an account, what will be the typical data that would be captured, or what do you think the data that will be stored in a table related to customers? So customer number will be there, right? Account number will be there, bank account number, and next you have the Aadhaar number. Okay, mobile number, address. Okay, and email ID. These kind of details will be there, isn't it, guys? This is all setup information. Okay, these are all used to find out the person. Okay, so now when you do transactions, so this particular data, this is called dimension table. Okay, dimension table or lookup table. Is it clear? Dimension or lookup. Dimension table or lookup table. Okay, so when you do transactions, what will happen? Suppose you have deposited say 5,000 rupees in your account, and next day you have withdrawn 2,000 rupees. Okay, now this is deposit and this is withdrawal. Now do you think these transactions will be stored in this table? It will not be saved in this dimension table. There will be a separate table that is called transactions table. Okay, so where your customer ID will be there and account number will be there, and then transaction, date of transaction, amount and place, all those things will be recorded here. Okay, are you all getting? So as you keep on transacting, this table grows. Each transaction will be captured. Okay, so this is called the fact table or data table. Are you all getting? So this is nothing but the transaction table. Transactions happen here. So you will get lot of numbers here, like how much amount withdrawn, how much amount deposited, when it has happened, where it has happened. All those details would be captured here. Okay. So similar to this, in any say in company environment, like say manufacturing company. So you are a car manufacturing company. Okay. So there you will be capturing the customer information, isn't it, guys? When you are selling a car, you will be capturing the customer information, like what is the customer name, customer mobile number, address. Okay, these details. Now, whenever the customer is purchasing, then you will record that in orders table, isn't it, guys? Or sales table. Order, not order, sales table. Okay, sales table, you will be recording the transaction, saying that customer number and the model the customer has purchased, amount or price. Okay, and date. Okay, and the salesperson name. All those things will be captured, isn't it? So this sales data is nothing but transaction table. Okay, or fact table, data table. Now, so in the transaction, in the dimension table, you will be having, in the dimension table, you will be having the primary keys. Okay, and in the transaction table, you will be having foreign keys. Okay, so keep these things in mind. There can be interview questions on those things. Okay, so now there are two different schemas in Power BI. Okay, one is star schema. You can just see this. So in star schema, what happens is the fact table would be at the center. Okay, fact table would be at the center, and all the dimension tables would be at the periphery. Okay, these are all dimension tables. So this is called star schema because it looks like a star. Okay, so at the center we have the fact table, that is data table, and on the sides we have the dimension tables. And this comes from relational databases. If you understand that in RDBMS or SQL, you might have studied about the normalization, right? One form normalization, second NF. Okay, different normalizations, single, double, triple, and 3.5. Okay, so since it is we want to maintain the integrity of the data, and also we want to reduce the redundancies, the normalizations are used in SQL. Okay, so since all the data is not available in single table, so the transaction tables would be the fact tables would be at the center here, and dimension tables would be at the periphery. Okay, so this is called star schema. So it is relatively easy to build this one. Okay, so now let us see how to build this star schema in Power BI. Okay, now we have just created this sales, just sales and territory. Now let us load few more data sets. Okay, customers. Okay, you can see. So when the data types are same, okay, and column names or data types are same, what happens is Power BI automatically creates a relationship between them. Okay, you can see one-to-one relationship between these two columns, customer key. Let us load another data set. Say product. You can rearrange. Just you can move it around. Okay. Are you getting how to arrange the data sets in the model?
Yes, sir.
Okay. Now you can see here the relationship is established on product key. Okay. Here we have on territory. Here we have on customer key. Okay. So here now this is a typical star schema. Okay. Now if you want to create visualizations around this, you can create visualizations. Okay. Now what we can do is we can just if you want to know the region wise sales. Okay. So just select stock bar chart and select region, and you can select the order quantity. Okay. Are you able to see region wise order quantity? Earlier it was not possible, isn't it? Earlier when we have only sales data or only territory data, we cannot do that because there is no relationship. If we just break the relationship between these two, if you just delete this relationship, it's not possible to see that visualization. Okay. Are you able to see? Okay. Okay. So this way we can, after we create the relationships, establish the relationships between different data sets, especially the fact table and the dimension table. We can answer various questions meaningfully, like region wise sales we can see here, or we want to see say country wise sales, you can just select the country, remove the region. Okay. You can see country wise sales here, Australia, United States, like this. Okay. Continent wise, you can see continent wise. Okay. So you can answer in different ways. You can answer different questions. Okay. Like you want to see product wise sales, you can see product wise sales, model name and sales. Okay. You can see different models, how much sales, quantity sold. See, there are 5 steps in Power BI. Okay. So first one is after you load the data. First one is loading the data, or connecting data and loading data. Okay. Extract, load the data. Next thing is transform the data. Okay. Are you all getting? So you need to clean the data. Basically, you need to clean the data. This is the second step and most important step. Third thing is data modeling. Now we are doing data modeling. Okay. So data modeling is nothing but establishing relationships between different data sets. Okay. This is the third step. Fourth step is to create visualizations. Okay. Or here in between, what you will get is you will get just a moment. So here you can write DAX functions. Okay. Data analysis expressions to create different calculations, different measures. Okay. And fifth step is visualizations. Okay. Okay. After you create visualizations, they can be created in pages, reports, okay, and dashboards. Okay, so these are three different things. We'll discuss those things. Okay, the final step is collaboration. Collaboration means you share these dashboards or reports with other people, okay, your colleagues or clients, anybody. Okay, these are the 6 steps. So here it is called ETL, Power BI also called ETL, extract, transform and load. Okay, so you connect to your data set and extract the data, pull the data inside Power BI. Okay, that is called extraction. T stands for transformation. Okay, this transformation, and after transformation you load the data. Okay, so after loading the data into Power BI, then we do data modeling, and if any DAX functions are required, we create those things, and then we create visualizations, and if required, we'll be collaborating. We'll be sharing the reports and dashboards. Okay, is this clear, everyone? Now, at any given point in time, you have to know in which stage are you, performing something or carrying out something. Okay. Okay, this is the star schema. Now let us see Snowflake schema. Okay. So this is a Snowflake schema. So here the fact table is at the center as in the star schema, and dimension table are at the periphery. You can see all the dimension tables here. Okay. And the change here or the difference here with respect to star schema is the addition of subdimensional tables. Okay, this addition of subdimensional tables is the new thing, or that is the change. Okay, so here if you look at it, typically this one is star schema, isn't it? This is star schema. So this Snowflake schema is nothing but an extended star schema or modified star schema. Okay, so here we have the subdimensional tables. Subdimensional tables means we have the dimension table, say product category. Okay, product category, say we have products like sports items or eatables or electronics items or household items. Okay, these are major categories or fashion related items, and within that you have different subcategories. Okay, like in electronics you have laptops, mobiles, uh, computers, cameras. These are all different products. Those are subdimensional. Are you all getting? And in the eatables you have vegetables, fruits or snacks, biscuits, those kind of things. Those are all subdimensional. So when the data is at higher level of normalization, this Snowflake schema comes into picture. Okay. Now let us see how to create a Snowflake schema in Power BI. So as we have seen, this is star schema. Now let us load another data set. Let's load product category and subcategory. So we have this product category keys. You can see bikes, component, clothing, accessories. Okay, let us load. Okay, are you able to see here? So product subcategory. Are you able to see product subcategory? So here we have the fact table here. We have one dimensional table here. So where here the mapping is product key. Okay. The relationship has been established on product key. And from this dimension table, we have sub-dimension table. Okay. Subcategories. And again, product categories. Okay. So this is the linkage that we need to establish in order to create Snowflake schema. Okay. Now, if you want to know the different categories, if you want to see the category-wise sales. Okay. So what we can do is we can select category name and sales order quantity. Okay. So this is the only matching one. It is matching. Okay. It is matching in all the tables. Okay. Only bikes. We do not have other matching data for other things. Even though we have, different categories here. Okay. Bikes is only having the data which is matching. So here I have few notes, guys, for your information. Just a comparison between star schema and Snowflake schema. So just for your information. So here in the star schema, the fact table and dimensional tables are contained. Here the differences are put out here. So star schema, we have fact table at the center and dimensional tables at the periphery. Okay. In the Snowflake schema, fact tables, dimension tables, as well as sub-dimension tables are also contained. Okay. Fact tables would be at the center, dimensional tables would be at the periphery of fact table, and sub-dimensional tables would be at the periphery of dimension table. Star schema is top-down model. Snowflake schema is bottom-up model. Okay, bottom-up means from the sub-dimensional level it comes. Okay. Star schema uses more space. Snowflake schema uses less space, because in star schema you have lot of data, whereas in Snowflake schema the data is available in higher normalization form, higher normal form. Okay, so it requires less space. And star schema takes less time for execution of queries, because it will not drill down to too many levels. Only at the center we have the fact table, and at the periphery we have dimension table. But Snowflake schema, it takes more time because it is having lot of levels. Okay, like you have this fact table at the center, dimension table at the periphery, sub-dimensional tables at the periphery of dimension table. So it has to fetch the data and compare the data at too many levels. So that's why it takes more time. So in star schema, normalization is not used, as we have discussed. In a Snowflake schema, both normalization and denormalizations are used. Okay. Star schema design is very simple. Snowflake design is a bit complex. Okay. So these are the few comparisons, guys.